So we'll leave that inside of the player class. Look around. So this is kind of an interesting thing. What do we have happen when we look around right now? Look around calls upon the current room display function. The current room's display function writes some stuff out to the screen. Says, here's the room you're in. Also here is this stuff, yada, yada, yada. So my question is, does look around stay inside of player, or does look around move into inhabitant, and why? What do you think? Anybody have any thoughts?
I think it would be rational to move it into inhabitant because then it would alert the player of any monsters in the room.
Okay, that's interesting. So it would alert the player. So let's think about that. So I would say that that's not necessarily an incorrect answer. It's probably not the answer I would have given, but let's kind of talk down that path. So what would happen in that case is when a rat enters the room and looks around, so to speak, what would happen automatically for the player is they would have, that whole rigmarole of here's the room you're in, all this stuff that would just reappear on their screen without them having done anything. So when the rat looks around, the player would see new stuff at that point, rather than having some alternative way, as you put it, to make sure a player becomes aware that, a rat just walked in. So maybe the player is notified in a less intrusive way, where maybe it just says a rat arrives from the east, something like that, just a single statement rather than a wall of new information about the room you're in with just one additional thing that says also here, and it shows a rat now. And
Yeah,
really,
that makes sense.
Okay, so does that make some sense what I just said?
Yeah.
So, but what ultimately, and the reason I asked this question, and the fact is that what you said is not wrong. It just might not be the best way of letting the player know. But hey, they would sure know something's changed as the thing is, the wall of text shows up on their screen. But we want to again come back to that idea of what differentiates a player from a monster. And the difference is that a player is controlled by a human, where the monster is controlled by the computer. And since the monster is controlled by the computer, having any sort of data output to the computer's internal screen, let's say, is maybe what we would be thinking about here, doesn't make a whole lot of sense. The rat really doesn't need that feedback about what room they're currently in or something like that. The rat's just kind of going through the motions, doing whatever the computer tells them to do, making sure they're in the current room. So I'd make the argument that since the display method in room does a whole bunch of system.out stuff, that goes out to the computer screen that the human being is looking at. Therefore, that's something that's dealing directly with the human interaction side of things. So I would leave that only in player. A rat can't look around, at least not in the same way. All right, get name. It's reasonable that both a player and a monster might want to be able to get their name. So we'll go ahead and get that out of there. Put it into inhabitant. Now, keep in mind that name was defined as protected, which means it's accessible inside the class called inhabitant, as well as any children of that class. So this idea of getting a name is really only needed if we want to be able to get the name of an inhabitant external from our game. For example, out here in main, let me get rid of this monster thing here. Being able to get this player's name by saying the player.getName out here in main. because main is not a child of inhabitant. Therefore, it would not, the way I'm teaching it, would not have access to the protected fields. So you would not have access to that function unless you made that function public. So we could probably make the argument that maybe at this point that function isn't even needed, since all players and all those guys have access to that. But the one difference here is in room. Room, when they say also here, they go through, well, right now they're just looking at the current player. We don't have inhabitants in rooms yet, but they're going to go through and they're going to print out the current player's name. And since room does not extend inhabitant, we would need to make sure that room has access to the name of that inhabitant. That's why we keep it as public. Their inhabitant here. So even though we've made these other things protected, in fact, we actually want to think about the set room. Is that protected? Let's go into here. I think we, inside of room, call set room. If it's not in room, then it's an exit. No, we do. We call it inside of our room. So that means back here in inhabitant, this guy, I had just changed it a few minutes ago. He actually needs to remain public. We need to have access to that set room outside of either any of the children of inhabitant. So all inhabitants can get their room set. All inhabitants can give you their name. Look around is going to stick with player. And right now a monster doesn't do anything because we haven't taught it how to do anything yet. Okay. Come back out here to main. We're building our couple of lists of things, building our map, building our player. We're no longer going to create an inhabitant. We'll go ahead and get the entrance to our map. We'll add the player to that entrance, and now we'll go ahead and tell our player to play. So let's just make sure that everything is still functioning the way we intend it to function. We'll move to the north. Now we're in the hallway, move to the west, so on and so forth. Okay, so we still have a working map where the player can move around our map, except now a player is built in terms of an inhabitant, where we've moved some of the functionality around so that inhabitants have the functionality that all inhabitants need to have. And player is a little thinner than it used to be because we've removed some of those common elements out and moved it into inhabitant. And monsters currently don't know how to do anything because we haven't taught it how to do anything yet. What do I call it? Exit? How do we get out? Okay, yeah, exit. All right. So let's go ahead and update our rooms to now hold a collection of inhabitants rather than a single player. Now, we can handle this a couple different ways. We could have, in our game, we're going to say our game here, just so we don't get too complicated with it. Our game is going to be a single player game. Certainly, if we think about the way games work today, a lot of games are multiplayer games. So, a room might have a collection of players in it where, you and I might both be playing at the same time. We might be sitting in the same room. That's something we can certainly expand our game to do. But right now, we're not going to go that route. Right now, there is one player in the map, but there might be many monsters. Okay. Now, because of that, because we know there's only one player, it would not be unreasonable for us to have a function or have a variable like we have in room right now, where a room has a current player. And then we have inside of room a collection of monsters. So private array list of monster called the monsters. So we'll teach a room how to have an array list of those monsters. And I'm going to talk about why we're choosing to do this like that in a second. And then in the constructor for room, we'll go ahead and say the monsters is equal to a new array list of monsters. Now, why did we choose to make the monsters an array list instead of a normal array? Why did we choose to do that instead of this? Why did we go this route rather than this route? Remind me.
We're holding objects and not addresses.
No, both these guys are going to hold. I mean, really what you just said, we're holding objects, not addresses. Objects and addresses are the same thing. An object is always going to, if we were to print out any object, it's going to print out the memory address of that object unless we overwrote the toString method. So this guy holds instances of monsters, so it'll hold memory addresses. This guy would hold instances of monsters, so he would hold memory addresses. The question is why did we choose an array list rather than a normal array? Really, I'm asking the question of what's the difference between an array? What advantage does an array list give us that an array does not?
Would it be so you can add monsters dynamically?
I think you have the right answer. What do you mean by add monsters dynamically?
I mean, so you don't have to add all the monsters at the start.
Okay, well, so it would make sense that we don't necessarily know how many monsters are going to be in a room right from the get-go, right?
Yep.
Especially if we're going to have possibly having rats roaming around our map. The idea is that we don't necessarily know how many monsters are going to be in a room at any point in time. And there might be 0 monsters in there. There might be 5 monsters in there. We don't know. And using an array requires us to have a fixed size for that. We could make it big enough to hold the most number of monsters we think might ever exist in a room, then somehow internally keep track. Or we can use an array list, which is elastic, and basically just adapts itself to the correct size. Truth be told, an array list actually does the same thing as this array does. If we were to use an array and then have some sort of counter to manage what's currently in that array, the array list effectively does that for us. When we add and remove stuff, it's going to make the array list bigger because the array list is built on top of a normal array. But from our perspective, from the programmer's perspective, this kind of animal automatically adapts to the size. We don't care how it accomplishes that. We just know that it does. Where this guy, we are in charge of making it big enough to hold the most number of things we ever want to hold initially. And then we have to keep track of how many things are actually in there, not how many things is it capable of holding. So that's why we're choosing an array list for this guy. We don't know how many monsters are going to be in this room at any point in time. An array list will accommodate that concept. Okay, so when a room first comes into existence, it will have 0 monsters in it. Okay, now when we display a room and we say also here, we first ask the question about the current player, and we either print out the current player's name or we print out nothing. But now we need to possibly spin through all of the monsters that we currently have. So we're going to maybe create a string here called also here output. We'll start that guy off as the empty string. if we do currently have a player, let's say also here output is going to be equal to that player's name. All right, so only if we currently have a player do we set that also here output string to that player's name. And then eventually we're going to say system.out.println also here output. All right, so as of right now, if I do nothing else, my room output should be the same as it was before. I'm just accomplishing it a little bit differently. Rather than directly writing to the screen, I'm building up a string that has the correct output. I'll go to the north, still giving me the output, so on and so forth. Okay. But the reason I'm doing this is because now what monsters are in this room? We need to go through that. So in order to do that, we're going to spin through all of the elements that are currently in our monsters array. So for int I is equal to 0, I is less than this dot the monsters dot size I plus plus. So we'll loop through every element of the monsters array. That could be 0 things currently. That could be 50 things currently. That's going to be a lot of rats. But, you know, we don't know how many things are actually in that room other than asking it, how many elements do you currently hold? That's what the monsters.size returns. And what we're going to do is for each one of those monsters, we're going to tack something on to the also here output. So we'll say also here output is equal to whatever it's currently equal to, maybe concatenated with a comma space, and then concatenated with this dot the monsters dot get at bucket I, which is going to be a monster. So this dot the monsters dot get at bucket I is going to be a monster. Why? Because the monsters was built to be an array list of monster objects. So this guy right here boils down to a monster, and we want to get the name of that monster. When we look at the monster class, we see, oh, well, he doesn't have a get name method, but we notice that he extends inhabitant. And when I go into inhabitant, all inhabitants have a get name method. So we will call the get name method of that particular monster. So this loop will go through all of the monsters that are currently in the room and tack their name on to the end of this also here output. So presumably there's already a player in there, and now there's some commas. So now we could ask the question, well, what if there isn't a player currently in the room? All of a sudden it would start with comma rat. Then let's say there's 3 rats in there. It would be comma rat, comma rat, comma rat. We might say, well, that's going to look weird. Well, if there's not a player in the room, nobody's going to end up seeing this because monsters don't look around. And look around is the guy that asks the room to display itself. So really asking that question right there, if the current player is not equal to null, is somewhat of a waste of time. We wouldn't actually ever call that. We wouldn't actually ever call this function if there wasn't a player in the room. I would still say it's good programming practice to logically say, hey, only show stuff here if there's a player in the room. And then similarly, if we only wanted to put a comma if the length of the thing was not equal to 0, then we could always ask a question in here, something like if also here output dot length is greater than 0, then tack on a comma in the name of the monster. Else, also here output is equal to this monster's name. That would cover the bases for that thing I just said, that we know as the human beings that are programming this, that only a person who's currently in a room would ever look around in that room. So we happen to know that this will always occur. But good programming practice might be to write code that is flexible in case somebody else goes and uses our objects for something. All right. So in this case, when a room displays itself, it'll say, is there a current player in there? If there is, go ahead and add his name to the also here output. Now let's go and process the monsters. Let's say there's 3 monsters in here. The first monster we run into, we're going to say, if there's already something in the also here output, presumably there's already a player's name, then we'll go ahead and tack on a comma followed by the name of this monster. Otherwise, we'll just go ahead and put the first monster's name inside of the also here output, so that the next time through the loop, now there's something in there, and we would tack on a comma followed by the next monster's name, and then the next monster be comma followed by the next monster's name. So now we've written it generically so that if somebody else does repurpose our room objects for something, it works correctly, let's say. But right now we know there isn't going to be any monsters in a room because we haven't actually added monsters. So if I go and run this now, it's going to still work the exact same way it worked before. We're just doing a little bit more ducking and diving in there. So we can still head north, we can still head west, so on and so forth. Okay. Well, now let's go ahead and let's put a monster into that first room. Exit. So we'll go into, I'm lost. So we're going to go ahead and build a monster. So we have our player. Let's go ahead and build a monster. The rat is equal to a new monster. Say rat. Okay, remember, monsters take a string as a parameter for their constructor, and then immediately just pass that to their parent, Inhabitant, for them to build this inhabitant in whatever way is reasonable. Then we go ahead and get the entrance like we did before. We add the player to the entrance. Now we're also going to add, now this is where things get a little bit weird. I need to be able to add a monster to a room. Because if I add a player, that's going to set that player's, that room's current player equal to the player. But in this case, I'm adding a monster. So we need to teach a room how to add a monster. I'll go ahead and just steal that function. We'll call this guy add monster. This guy will take it a monster M. Now, rather than just replacing the current player with that monster, we're going to say this dot the monsters dot add M. So we will tack this monster onto the current room, the room that monster is currently in. And then we want this monster to be aware of the room that they're currently in. Remember, we taught inhabitants how to have their room set. So an inhabitant gets to know what room they're currently in. So even though we are adding a monster to a room differently than we added a player, because a room keeps track of their single current player and then keeps track of an array list of all their monsters. In both cases, we're going to let the inhabitant that was passed in know about the room that they're in. The rat needs to know what room he's currently in. We don't know how he's going to use that, but it would make sense that if a room knows it has a rat, the rat should also know it has a room. That's going to benefit us when we go and make this rat start moving around. Okay, so now we have the ability to add a monster, which just puts them onto that array list and then sets that guy's room. We'll say add monster, and let's go ahead and name it the rat instead of the rate. We'll add the rat to the room, and then we'll go ahead and play. And now we're going to see that we notice there's also a rat in that room with us. All right, makes some sense. Now, right now, that rat can't do anything. So we want to build in the abilities for this rat to move. Now, as of right now, we don't necessarily have a way to make a rat actually move on its own. All right, maybe we tell a rat to go ahead and wait some amount of time and then start doing something. Maybe it looks at the current exits, it picks a random exit, moves into that. So a rat kind of has a mind of its own, if you will. But in order to prepare for that, we're going to go ahead and initially give the player the ability to take another thing that's in the room, like a rat, and throw it through an exit, building in the ability for a rat to move from one room to another, except they did it by the hands of a player. Okay. Then we're going to teach them next class how to move on their own. So we want a player So if we type in throw, then we'll ask the player system.out.println print, who do you want to throw? And then we'll go ahead and repurpose line and get input dot next line. Go ahead and run this. So now we've taught a player. Oh. So I'm in this room, and now I can type in throw. And when I type in throw, it's going to say, who do you want to throw? And I'm going to say, well, I want to throw the rat. Now it's saying about to throw the rat. Okay. We're going to say, who do you want to throw? 1 second. run it one more time because it was a weird spacing thing. I just want to fix. Leave you with good code. Oh, so it's who do you want to throw? Put a space after that. And actually, maybe we don't reuse line. We say we have string who. Then we have system.app that println. Where do you want to throw? Something like that. So we'll ask, who do you want to throw? We'll read that in. We'll ask, where do you want to throw them? We'll read that in. And then we'll say, we're about to throw the whoever, the who, through the exit to the where. So let's see that go down. I should be able to type in throw. Who do I want to throw? I want to throw the rat. Where do I want to throw them? I want to throw them to the north. I got to do a print instead of a println. Now it says about to throw the rat through the exit to the north. Okay, so now for your homework, save on this, share. For your homework, make it so that that rat actually gets thrown. So that when I go to the north, I now see the rat in the room. Given this, finish implementing throw command such that a player looks around after a monster is thrown and sees that they left the room. And then when the player moves in the direction that the monster was thrown, the player should see the monster in the new room. With a link, code, and self-eval. So we're teaching monsters how to move from one room to another, but the way they're getting there is by the player throwing them. Next time we'll talk about threads so they can kind of move around on their own. Questions what I'm asking you to do?
I have a question on this assignment. This Saturday though, for the hackathon,
Yep.
is it a 5-hour, are you there from 12 to 5 or how does that work?
Yeah, so it's I think it's set up for 5 hours. So it's what they would call a mini hackathon. So typically hackathons last, well, a lot of them will last 24 hours, but historically we've run them as 12-hour hackathons. So basically you'll come and they'll break you into teams and there'll be like a small project that you're going to work on with some juniors and seniors. So upper division students, you'll learn how to create something kind of from scratch, something you haven't necessarily done before. But you'll learn some new stuff during that. Does that kind of answer your question?
Yeah, thank you.
Mm-hmm. All right, anything else? All right, I will see everybody on Wednesday.